Hello, welcome to ISAT 211, Issues in Modern Production Systems. And this is lecture 10, Engineering Economy. So today I want to discuss why we are learning engineering economy and how that can be used in industrial manufacturing systems. First, money is always an important part in engineering because and also manufacturing, because all the equipment, resource, everything is related to the cost and money, right? And a lot of decisions are ultimately based on the availability of the capital as well. So we need to understand how the economic aspects of the work actually related to your production activities. Yeah, for example, how many people is willing to buy $100,000 laptop, and how a laptop price is determined based on the cost, the margin of the profit, as well as some other factors. And because if a company cannot make money, it cannot survive, right? And typically there are different type of problems are related to the money from our everyday life. We see that we use cash or credit card to purchase things or buy milk, or sometimes we can meet some intermediate problem. For example, you want to buy or lease a car, which one is more economic to you, and you may want to do a little bit of calculation and then consider which option do you want to go with. And same thing is, machine A or machine B, you want to buy for a new assembly line. And then you may want to look at the depreciation of the machines, the functionality, specifications, and also, the cost of the machines, and then make a decision. So that's the more intermediate problem. Sometimes we may see some very complex problem. For example, if you are going to build a new plant in Asia or in South America, then there are a lot of different kind of costs you have to consider, right? Not only the human resource, but also the land, everything, a mixture of economic, political, and also domestic elements. So these are all related to the cost itself. That's why we need to have at least have a very basic understanding from this course that are related to industrial manufacturing production activities. And some examples of engineering economic analysis include, for example, which project was well, right? Is there enough oil or mineral deposit to make the project was developing? And also, which project may have a higher priority? Maybe both projects will work, but which one give us more return, right? More return does not mean that the project have a really high cost. So it really depends on the ratio and on the return itself. And also sometimes we may have multiple designs of the projects or products. Then you can start to look at or evaluate profit and benefit analysis, cost benefit analysis, and see which design might give you a better return. So these are all the example problems we can solve with the engineering economy. And well, one term or one concept about in here is the time value of the money. So we know that time has value. Think about this problem. You won a lottery that is $300 million, and now you have option is take your winnings, right? $12 million per year for 25 years. You still got $300 million over 25 years. Or another option is you take the all the $170 million today, right? And so which one do you want to take it? Do you want to take it for the first option or the second option? Well, if you take the second option, it seems that you actually lose 130 million dollars. Well, is it the case? No, not really, because you will see with the 5% interest rate, the two actually is equal to each other. Why? Because there's a time value of the money. Because think about this case, $1 million 25 years earlier, that was maybe 1997. Then how much can you buy with $1 million? But now with $1 million, how much can you buy now? Right? There's a big difference of the value of the same amount of dollar. Right? So that is the time value of the money. So that's why even though that you are taking $12 million for 25 years and added them all together is $300 million, the value you get is actually less than $300 million compared to you get all of those $300 million at the very beginning, right? So then how much is it equal to each other? Then you will see the $300 million, if you get it for over 25 years, that is actually only equal to $170 million today. So, but what about, if the interest rate is higher than 5%, say the 7% or 10%, then you'll see that $170 million is actually more than $12 million per year for 25 years, right? So it really depends on interest rate, because interest rate is something that moves the value of the money. All right, so when we're talking about the money has a lot of powers. So money has a purchasing power. You can buy things with money, and also you can earn, right? You can earn money from money. That's called investment, right? And so money is a valuable asset. People usually say that money is not the most important thing for a company, but it's actually the only important thing in a business, because other activities our decisions are made based on the money itself. Even though you're saying you are doing a lot of charity or a lot of maybe social responsibility works or environmental work, is still that is closely tied with your economic profit and cost. And a lot of times people are willing to pay some extra charges to use the money, right? So for example, you lend some money for some investment. Well, then you pay the interest, but you can use the money to get some earnings. Say you have a business idea, right? You take a loan from the bank, so you can use that kind of that money to build your business. You can use your business to earn a lot more money. So this is also the power of the money. So money has time values, which means that money changes its value over time. This concept you really need to understand. Because money changes its value over time, we cannot do add or subtract at different times of the money. So we can only do all these calculations or subtract or add when they occur at the same time. And so then someone may ask that, okay, how can I compare the value say $1,000 now, maybe after 2 years I got another $1,000, and then after 3 years I got another $2,000. How do I do the calculations? Well, if you know the interest rate, you can actually convert those future $1,000, all those cash flows we call it, and to a common time. Either you convert all these cash flows to the beginning of the time, which is now, or convert everything to the future, right? So using interest rate. And this is how we can do calculations with money at different time periods, to use interest rate to move the money forward and backward in time. And there are some concepts related to our terms related to the time value of the money. One is the principal. Principal basically is original, investment or original, money you put out there, and it can be a investment from yourself, your money, your own money, or it can be a loan, right? And interest rate is we all understand the interest rate is basically it's a percentage, right? Of the original amount per time unit. So basically, for a certain time unit, how much the value changes, right? That is percentage. This is the expression of interest rate. And the interest is basically it's an increase of the value, right, for a certain period of time. And so interest is also the charge of the for the use of the money. And though this is an equation of how to calculate the interest interest rate equals to the interest per time unit divided by original amount times 100%. So you got interest rate. And now let's look at one example here. Say Joe took a loan of $20,000 and paid it off the loan, and the principal is $22,500 after 1 year. So what is the interest rate for this loan? And now we have this equation. We can look at, okay, how much the value it actually increased, right? For this $20,000 loan, it is actually $22,500, right? So how much increase? That is $22,500 minus the $20,000, and then this is the increase divided by the original amount, which is $20,000, and you will get the percentage, right? The percentage of its value increase. That is 12.5%, and this is the interest rate, right? What about interest period? Because everything happened in 1 year, right? In 1 year. So that is interest period will be 1 year. This unit. Let's look at two different kind of interest. One is simple interest. The other one is compound interest. So simple interest means the interest is only computed on the original sum and not on accrued interest, right? So basically, say you have multiple periods, for the first period, and it generates some interest, right? Well, if you are on the second period, basically you are only charging the interest that is for the original loan or original amount of money, which has happened at the beginning of the first period. You are not charging or generating interest, additional interest from the interest from the first period. This is what it means, simple interest. And how do we calculate for simple interest? How can we do calculate the future value based on simple interest? That is to use F equals to P times 1 plus I. So I is the interest rate, and the N is what? N is the number of period, right? And the number period. So an example for this simple interest rate or simple interest will be same story. You loan $10,000 to a friend for 5 years at 10% interest, and how much will you get at the end of 5 years? With the simple interest, now we know that we never charge interest on interest, so we only charge interest on the original loan, $10,000. So how many years we charge those? 5 years. So 10% times 5 times $10,000, and you get the total interest that you earned over the 5 years. That is $5,000. And using the equation here is F equals P times 1 plus I times N. So this is how you calculate the future value of the original loan, right? Future value of the original loan. And that is for simple interest rate. Another type of interest, which is more common in our life, is the compound interest. So compound interest means interest on top of interest. So in a simple interest rate, we do not charge interest on interest, but in compound interest, we charge interest on the prior interest, right? So it means interest is calculated based on the principal and interest owned. And now let's look at it, the same example here. You loan $10,000 to a friend for 5 years at 10% interest with compound interest. Let's start with the first period, and we see that the original loan is $10,000, and based on the first year's interest, which is 10%, the interest you earn is actually $1,000. Then what you get at the end of the 1 year, you will get $11,000 at the end of year one. Well, when they get into the second year, which is year two, and the original amount becomes $11,000, right? $11,000, and the interest will be another 10%. Will be another interest based on the $11,000, which becomes $1,100. Now, added them all together, you will get 12,100. So this is a interest on top of interest, or we call it compound interest. And then keep doing all these calculations. You will see after 5 years, the amount is actually $16,000 and $16,105, right? Compared to the simple interest rate, and you will see you'll get is only $15,000. Here you actually got more than $16,000. So this is how the difference between the simple interest and the compound interest, right? This is a difference between the two interests. And how if you want to use the equation to calculate the compound interest for future value, this is the equation. Future value equals to the principal or present value of present value times 1 plus I is interest rate per period, and to the power of n. N is the number of periods. Okay. So another concept is equivalence. Equivalence basically, it's how much value is actually equivalent to the value at a different time. And so the equivalence is really depend on the interest rate. So taking an example of from the previous example, same thing here, and you will see a simple interest rate that is actually a loan of $10,000 is equivalent to $1,500 after 5 years. Well, if it is compound interest rate, we can say that a loan of $10,000 is equivalent to $16,105 after 5 years. So this is what it means by a equivalent. And so what about if we change the interest rate, what's going to happen, right? So say here, if it is 5% interest rate, you can calculate the total sum of the 5% interest rate after 5 years is $12,000 and $500. $1,200 and $500. Sorry, $12,500, and the compound is $12,763. You'll see it's $263 more than the simple interest rate. Well, if it is for 10 years, it's more than $1,000 difference. And so when we are solving engineering economy problems, one diagram to help us to understand the case is understand the cash flows is called cash flow diagram. So first, what is cash flow? So cash flow is the receipts and the disbursement. So basically the money coming in or going out, right, to you. And so the receipts and the disbursement in a given time interval with the positive cash flows usually representing the receipts, and negative cash flows representing disbursement. So which means positive are the money coming to yourself, right? That's a positive. Well, the negative means you give out money, right? You give out the money. So, and the net cash flow equals to receipts minus disbursement. So now let's look at which of the following examples does not illustrate the cash flow. The first one is, you write a check to pay your gardener. So that's, you are paying money to your gardener. That's the cash flow. Well, you pay $100 for a cup of lemonade from your neighbor's lemonade stand. Well, this is cash flow, right? You pay money to the neighbor. You pay for coffee using debit card. Yes, money goes out from you. And then the last one is you buy garden fences from a local gardening store on account. So pay attention here. On account means you are using some credit to buy it. Credit and cash are different, right? Are different. Here it's not talking about cash. It's talking about the credit itself. So it's this one does not illustrate a cash flow. And cash flow diagram is a diagram to help us understand the activities. And so what we usually do is we use end of the year convention. So which means that, all the cash flows occur. We assume that all cash flow occurs at the end of the interest period, right? And the components of the cash flow diagram include, a time horizon line, vertical arrows to represent the cash flows, and also include interest rate. For example, this cash flow, right? You have this, horizontal line to show the time horizon, and then you have these up and down arrows to show the cash flows. Positive, that is you receive the money, right? Receipts, money come to you, and negative means money going out from you. And keep in mind that every time you draw a cash flow diagram, you should include interest rate here. Right? For example, if you draw this example, $8,000 loan at a rate of 10%, the loan is to be repaid over 4 years at this amount. So 8,000 loan, which is the original loan, means what? Means say you get a loan from the bank. The bank is actually giving you the money, right? So which means that you receive the money, right? You receive the money. So the loan is receiving, right? You receive the $8,000, then you have to pay it back. To pay back means you are giving out the money, right? Money is leaving you. And when will these cash flows happen? See, over 4 years at this amount, right? Year 1, year 2, year 3, year 4, right? This is all the same amount, $2,500 and $2,500 and $224. All right, so this is how we draw the cash flow diagram. Make sure you mark the interest rate, which is 10%. And well, that's from you, from the borrower's perspective. What about from the lender's perspective? Is that right? It's quite the opposite, right? So because $8,000 becomes what? If you're a lender, you're actually lending money out. I mean, the money is actually leaving you, right? So that's why the $8,000 is actually a disbursement, which is a negative, leaving you, and then you collect the money back, right, over the 4 years. So this is how you draw the cash flows. All positive over 4 years. Make sure you include the 10% interest rate. And now, we can use an example that you loan, $10,000 to a friend for 5 years and 10% interest rate. How much will you get at the end of the 5 years? Well, think about how many cash flows will happen. Well, it only happens in 2 cash flows. One is at the beginning time, right? You loan $10,000 to a friend, which means that those $10,000 actually is leaving you, right? You give out $10,000. And then later you will get at the end of 5 years, you receive the money back, right? You receive the money. So there are 2 cash flows. One is positive, one is negative. Positive happens, at the end of the 5 years. That's the money you receive at, when your friend return you the money. Well, the $10,000, which is the giving out the money of the loan, that you is enacted, at the very beginning. And so for different there are different categories of cash flows. For example, the first cost usually that is expenses that happen in the very beginning, and also you will see every year there may be some cash flows for the project or for the machine. Usually we call it operations and maintenance, and also at the end of the life. There's a salvage value, so which is the receipt that the money amount of the receipt at the project termination, right, for sale or transfer equipment. And also you may get revenues, which is the annual receipts due to the sale of the product and services, and overhaul, which is the major capital expenditures that occur during an asset's life. And cash flow diagram, we can when we are calculating cash flows, for future value and for present value, there are two different ways we can express it. One is, of course, to use the equation like future value equals to present value times 1 plus I, the interest rate to the power of n. Well, another one is to use the functional notation, so which is to write like this, right? So within the parentheses, what is this? What it means? Means we want to find the future value given what? Given present value, interest rate, and how many periods, right? How many periods? So this is what it means by functional notation. Why do we use functional notation? Because people have developed, right? People have developed tables to calculate, this part, only this part, right? Only to calculate this part. We can actually use table to find those values, right? Regardless of what this P is, regardless of what P is, this is always the same, always the same. So that's why, as long as I know the interest rate, and as long as I know how many periods, I can find this amount of value. So that's why if we show this, and we can actually easily using this use this equation, this notation, to find out the money of this part, and then all we need to do is just to find the present value. And so this is the equation showing here. Now let's look at with this example. We can draw a cash flow diagram like this with notation. How do we show it? So first, F equals to P times this future value calculation. This notation means I want to find a future value at given present value, interest rate, and also number of periods. All right. So what is the P, which is the $10,000, right, for the present worth or present value, and times this middle part. So now all we want to do is to find out, okay, what is the value for this notation, right? And there is a table you can use to find out this value. And method one is you can convert this to an equation. Well, equation will be like this, right? 1 plus 0.1, this is 10% to the power of 5, and you can calculate this. Another method is to use a table like this, right? Use a table like this, and we can find out, okay, what is the interest rate, and also how many periods, right? And also which payment is that? Is this single payment, or is equal payments? Because it's a single payment, means it's all the cash flows at the same time. So we can find this value, which is 1.6105, and then after we found this part of the value, then all we need to do is just to time the present value, which is 10,000. This is how we can get the same value, right, as what we get from the equation. So these are the two methods you can do, and if you want to do the comparison, it's the same. It's just and one method is using notation, and the other method is using the equation. There's also another method which is to use Excel. So using Excel, and all you need to do is define the variables. So define the variable present value, interest rate, define the variable of a number of periods, and then you type. If you are looking for a future value, then you type FV parentheses, and you will see all these different variables. Well, first one is interest rate, right? And per the NPER, this means that number period, and this is the payment, right? This is a payment for each period. A lot of times we are not actually using this, right? And then next one will be the present value. The next one will be the type. So the type means if you put that 0, that is end of period. If it's put 1, that is beginning of period. But the default value is actually 0, right? All cash flows happen at the end of each period. So you can leave it at empty. And when you type the equation, this is when you type first interest rate and then the number of periods. Because there's no equal payments during all these payments, we just leave it at the space or add another comma to skip it, and then the next one will be the present value, and then you will see this is how much you get, right? Someone may ask, why do I put negative here? That's because this is it depends on it's a loan or it's the money coming in or going out. So you can put this positive and negative sign here. In prior examples, we look at the calculation of finding future value based on the present value. Now, how can we calculate the present value based on the future value? It's pretty much the same. All you need to do is just to rearrange the formula, the equation, right? Because only have 2 variables, and you'll see the formula for the equation for calculating present value equals to F times 1 plus interest rate to the power of negative n. So pay attention here. It's negative n. It's not 1 minus I. So in the past, I've seen a lot of people actually when they convert it back to present value, they use the 1 minus. No, it's not minus I. It's 1 plus I to the power of negative n. So this is the equation of calculating present value of the cash flow. And for the notation, it's similar. Because we understand the structure of the notation, so which means that we want to find the present value given future value of interest rate and also the number of periods, right? And then use this to times the present value, future value. Then you will calculate the present value. If we use this example, say how much money we will invest today at the rate of 5% per year in order to accumulate, $50,000 in 5 years. We know the future value we want to get is $50,000, but we want to calculate what is the present value now. So first of all, we'll draw a cash flow diagram, right? This is a cash flow diagram, and there are 2 cash flows showing. One is you invest money and money going out of yourself, that is a negative. And then another cash flow will be that at the end of 5 years, you will receive money and receive $50,000. And then what you want to find out is what is this P value, right? How do you find out the P? We got to use the notation, right? Notation, and then find, okay, this is a 5% interest rate. And how many periods is 5 years? So, and we are looking for what? We're looking for a present worth factor, right? So it means we are looking for present value, not future value. We're looking for present value, and then find out what is this factor is 0.7835. And then just use this 0.7835 times $50,000. You will get 175. So this is how we use this table to solve this problem. Or we can also use the Excel to do that. So that is present value equals to this equation, right? The only difference is this, right? If you are looking for future value, this will be present value. If you are looking for the present value, this will be the future value. All the other variables are the same. And so now let's look at what it means. The solution will be $39,000 or $39,175 for the present, for the you need to invest today, right? It's needed today in order to get $50,000 Fed interest rate in 5 years. And now let's look at a practice problem here. First one is for investment of $12,000 now, $2,500 over 2 years from now, and $3,000 4 years from now at an interest rate of 5% compounding annually. What is the total amount you can withdraw 6 years from now? So which means there are multiple cash flows over the 6 years. First, let's draw a cash flow diagram, which is like this, right? $2,000 from now, $2,500 2 years later, and then this is 4 years later. These 3 cash flows. Now we want to calculate what is the total amount of the value for the future value of these cash flows with interest rate of 5%. We know how to convert each one of those, right? Convert this one to 6 years later, right? Convert this one to how many years later? 4 years later, right? Convert this one to 2 years later. So this is how I just added them all together. You will find the future value. Now, if you look at the equation, notation or equation, and this is what we need to use, because if you're looking for, a present value, then we can use this equation. If you're looking for a future value, this is what we get. So to set up the equation, because we want to find out the future value, so these are notation version, right? This is 6 years, so which means that this is for 2000 setup, right? 6 years from now. 4 years for cash flow. Second cash flow, another cash flow is $3,000. That is only 2 years from now, right? So this is the notation setup. And then you can look up all the values from the tables, and this is what you get. And you can find out the total value is actually 9,226.45. Well, you can also use Excel to do it by yourself, right? I'll just leave it to you. Let's look at another problem. You deposited $200 in the bank today, and you plan to withdraw $1,500 6 years later. From 6 years from now, if the bank pays 5% interest, how much do you need to deposit 4 years from today? Now, it seems a lot of things going on, but let's draw a cash flow diagram. It will make it a lot easier to see. So basically, you deposit $200 from now today, right? Today, that's the cash flow, $200, and then you plan to withdraw $1,500 6 years from now today, and then if the interest rate is 5%, how much do you need to deposit 4 years from today? So this is a cash flow diagram. Well, we know how to do all these conversions, single cash flows. Now it should be pretty straightforward, right? We can multiple ways we can do it. First, we can convert this $2,200 to year 4, to convert this $1,500 to year 4 as well. In this case, for this cash flow, we'll be looking for a future value. And for this cash flow, we'll be looking for a more present value, right? 2 years back. So this is this is a setup of the notation, and we can solve it with the tables to do that. Okay, so now we're converting everything to x, right? Converting everything to x. The year 4 x. You can easily find the value, which is this amount. Well, another method is to convert everything to year 0, right? To the current, and then you have to convert year 4 is x, right? To the time 0 also. It may be add a little bit of complexity, but it should do the same thing, right? So this is what we can calculate with different methods for these cash flow problems. All right, that's all for today.